Let us talk about hypothesis testing for a population mean when the population standard deviation is unknown. So to test a claim about a population mean when the population standard deviation is unknown, we can use a t-distribution. So that is t equals the sample mean minus the hypothesized mean over the standard error. So when these conditions are met, the sample is random. 2, at least one of the following is true, the population is normally distributed, or the number of samples is greater than or equal to 30. Now the degree of freedom is equal to n minus 1. So how are we going to find the critical values for a t-distribution? So we have the following steps. 1, specify the level of significance. 2, identify the degree of freedom, which is n minus 1. 3, find the critical values using the t-distribution. So this is the t-distribution table. Now, for a left-tail test, use the one-tail alpha column with a negative sign. For the right-tail test, use the one-tail alpha column with a positive sign. And for the two-tail test, use the two-tails alpha column with a negative and positive sign. So the rejection region for the left-tail test is at the left of the critical value. The rejection region for a right-tail test is at the right of the critical value, and the rejection region for the two-tail test is at the left of the negative critical value and at the right of the positive critical value. So let's have the following examples. Find the critical value for a right-tail test with the alpha 0.01 and n equals 17. Now using the t-distribution table, the df is equal to n minus 1. So n is equal to 17 minus 1 is equal to 16. So since this is a right-tail test, we're going to look at the one-tail alpha. That is 0.01. This is the 0.01 and the df is 16. So that is one-tail alpha 0.01, df 16. So the critical value is equal to 2.583. Next, let's have this example number 2. Find the critical value for a left-tail test where the alpha 0.05 and n equals 21. So using the t-distribution table, so the df is equal to 21 minus 1, which is 20. Now left-tail test, so still we're going to look at the one-tail alpha 0.05. So this is a 0.05 one-tail alpha and the df is 20. So one-tail alpha 0.05, df 20, the critical value is 1.725. So since this is a left-tail test, the critical value is negative. So that is negative 1.725. So let's have this example number 3. Find the critical value for a two-tailed test with the alpha 0.10 and n equals 26. So the df is 25, that is 26 minus 1. So since this is a two-tailed test, we're going to look at the two-tails alpha 0.10. This is a 0.10 and the df 25, this is 25. So 0.10, two-tails alpha and df 25. So the critical value is 1.708. So the critical values are negative 1.708 and positive 1.708. Now, in every hypothesis testing, the decision rule is very important. It tells us when to reject or to accept the null hypothesis. So the decision rule for the t-distribution is this. If the computed t is in the rejection region, then reject the null hypothesis. Otherwise, fail to reject the null hypothesis, meaning we're going to accept the null hypothesis. So let's have this example number 4. A used car dealer says that the mean price of a 2-year-old sedan in good condition is at least $20,500. You suspect this claim is incorrect and find a random sample of 14 similar vehicles has a mean price of $19,850 and a standard deviation of $1,084. Is there enough evidence to reject the dealer's claim at alpha 0.05? Assume the population is normally distributed. So let us identify the given. Now, the hypothesized mean here is $20,500. The sample mean is 19,850. The sample standard deviation is $1,084. Now, the alpha is at 0.05 and the number of samples is 14. Now the DF, that is n minus 1, so 14 minus 1 is 13. So the degree of freedom is 13. Now let us identify the null and the alternative hypothesis. The claim of the car dealer is that the mean price of a 2-year-old sedan is at least $20,500. So meaning the minimum price is $20,500 and it can go higher than $20,500. So the null hypothesis is the mean greater than or equal $20,500. And the alternative hypothesis is less than $20,500, which is just the complement of the null hypothesis. So I actually have a video about stating the null and alternative hypothesis, so it can help you with stating your hypothesis. So I'm just going to put the link in the description box below. Now let us identify the critical value. Now, since the alternative hypothesis uses the less than symbol, meaning this is a left tail test. Now, the alpha is 0.05 and the DF is 13. So left tail test, we're going to look at the one tail alpha, that is 0.05. Then the DF is 13. So that is 0.05. DF is 13. Now, the critical value is 1.771. So since this is a left tail test, the critical value is negative. So that is negative 1.771. Now, draw the normal curve and specify the critical value. So this is the critical value, and to the left of the critical value is the rejection region. Now let us compute the test statistics. So that is the sample mean minus the hypothesized mean over the standard error. So the sample mean is equal to 19,850 minus the population mean or the hypothesized mean, which is 20,500, over the sample mean, that is 1,084, over the square root of n, which is 14. Now computing this is equal to negative 2.244. Now negative 2.244 is within the rejection region. So meaning we're going to reject the null hypothesis, which is the claim of the car dealer. So therefore, there is enough evidence at 5% level of significance to reject the claim that the mean price of a 2-year-old sedan is at least $20,500. Now let's have this example number 5. An industrial company claims that the mean pH level of the water in a nearby river is 6.8. You randomly select 39 water samples and measure the pH level of each. The sample mean and the standard deviation are 6.7 and 0.35 respectively. Is there enough evidence to reject the company's claim at 0.05? So let us identify the given. So the hypothesized mean here is 6.8. The sample mean is 6.7. The sample standard deviation is 0.35. The alpha is 0.05. And the number of samples is 39. So to find the DF, that is just 39 minus 1 is equal to 38. So the DF is equal to 38. Now let us identify the null and alternative hypothesis. So the company's claim is that the mean pH level of the water is 6.8. So therefore, the null hypothesis is mean equals 6.8, which is the claim. Now, the alternative hypothesis is just the complement or the opposite of the null hypothesis. So since the null hypothesis is equal, so the alternative hypothesis is not equal to 6.8. Now, let us find the critical value. So using the t-distribution table, so since the alternative hypothesis uses the not equal to symbol, so meaning this is a two-tailed test. So we're going to look at the two tails alpha. So the alpha is 0.05. So two tails alpha 0.05 and the DF is 38. So two tails alpha 0.05 and DF 38. So the critical value is equal to 2.024. We have two critical values, one negative and the other one is positive. So the critical value is equal to positive, negative 2.024. Now let us draw the normal curve specifying our critical value. So the critical value at the left is negative 2.024 and the critical value at the right is 2.024 positive. Now let us compute the test statistics. So that is sample mean minus the hypothesized mean over the standard error. So the sample mean is equal to 6.7 minus the hypothesized mean, which is 6.8, over the sample standard deviation, which is 0.35, over the square root of n, which is 39. Now computing this, the t is negative 1.784. So negative 1.784 is not in the rejection region. So meaning we're going to accept the null hypothesis, which is the claim of the industrial company that the mean pH level of the water in the river is 6.8. So therefore, there is not enough evidence at 5% level of significance to reject the claim that the mean pH level is 6.8. Thank you.